Okay, I'll just start. For those of you who do not know, Unikraft is an open source library operating system and software development kit that's primarily run by a number of open source contributors, mainly NEC. Its primary goal is to create lightweight virtual machines. They're bespoke. They follow the idea that compartmentalization of a service can be done through minimal abstractions and through reducing the overhead. So you can think of them as an alternative to containers. They're quite clearly not, but they have a similar concept in this way. And when deploying them in a similar kind of context, they feature a number of similar networking traits. It's still very much under active development, and there's still lots of things coming through. And if you follow the mailing lists, you'll see patches sent every day. But today, I'd like to talk a little bit about how we implement the socket abstraction within Unikraft. By the way, hi, I'm Alex. I'm a PhD student at Lancaster, but I'm currently doing an internship at NEC. So yeah, let's get started. So today, hopefully, is largely a discussion, but to back it up, I'd like to give a bit of a primer. Yeah, with the discussion, it's talking a little bit about what sockets are and how we do I put P for process-like virtual machine communication, in the sense that these lightweight virtual machines almost represent processes, and that we can do communication between them. So it's also looking at use cases, applications, etc. So to back this up, there's been a number of different ways in which we've historically been able to introduce communication between virtual machines. It started a little bit, I think, primarily with this piece of work called XenSockets back in 2007. That introduced a Linux kernel module to DOM0 and to DOM-U guests that would allow communication via the socket API. And this would basically map memory between the DOM0 and the DOM-U guest via sharing a reference in XenStored. We then had subsequent bits of work developed, such as NetMap, which was later used in ClickOS, or if you do not know, was a unikernel implementation of MiniOS, which is the paravirtualized, I wouldn't necessarily call it a library operating system. It is a unikernel implementation, since it's not largely extensible. People had to do a lot of work to get things to work on MiniOS, and ClickOS was one of these results. And there's a way of running this kind of mapping of pages with NetMap on ClickOS. Then came NTCP a few years later, which follows a very similar process, in the sense that it's doing the transfer of packets through multi-core systems. Later on, we've had a very similar implementation with VirtIO VSock, which is the KVM implementation. And so this is, in the Linux kernel, a way of, it's a very similar concept to XenSocket, passing a particular AF family number through the socket interface to basically dictate to the kernel that you are about to start a communication with another virtual machine, and not necessarily through the IPv4 and TCP stack. And even more recently is Argo. I've actually not been able to play with this, so if anybody has any experience using Argo and being able to work and has used Argo, then that would be really appreciated. To start the primer, I think this is, whilst this is still ongoing work, the premise is that in one unikernel, so we have something running here as a DOM-U guest, we can open up a socket and we can provide it with an AF number, such as AF_XEN in the case of XenSocket, or AF_INET in the case of a TCP IP stack. This socket is provided through a global interface, which we call internally through Unikraft POSIX socket. It's a module that you can enable when you construct a Unikraft unikernel, And when you do so, you expose these primitives, the socket, the bind, listen, sending and receiving messages, connecting, etc. Everything that you kind of expect through a POSIX compliant system. What we do internally is we provide a switch to different socket implementations based on this AF number. So if you were to say, for instance, AFZen, you would then use the implementation that provides that AF number. If you use AF-INET, you would then use the implementation that provides AF-INET. In our current case, we have the lightweight IP stack, which is what provides the AF-INET stack and provides much of the networking internals for Unikraft at present. But you can similarly create other implementations, should you wish, to be able to still use this socket and POSIX compliant API abstraction without having to actually make any modifications to your application code. So the idea is that with Unikraft, you can port an application very simply by compiling against the Unikraft SDK using tools such as Craft and using the makefile and kconfig system that is the Unikraft intrinsics. So with this minimal modification, we're able to then bypass the TCP IP stack and then potentially communicate with another unikernel running on the same host, which would then just share a memory, for instance. So this would be the XenSocket implementation. This is a way of doing it. This is very much ongoing. Things are not necessarily upstream; they're working, but there should be patches relatively soon. When regard to creating a implementation or porting an implementation, such as LWIP, there's also other implementations such as Pico TCP, which was designed with a near POSIX compliancy. It is slightly different. Some of the socket function names don't have the same prototype as standard POSIX, but that doesn't mean that you can't use them in a very similar way. And so what you do is you create a simple wrapper around your socket, and you pass something called the socket driver interface or structure, which has a number of bits of information, such as the library that is calling, most importantly, the AF family number. So this would be AF-INET, for instance, or AF-INET 6 for IPv6, and then any additional processing that's required by your maybe POSIX, maybe non-POSIX compliant socket API could basically wrapped in this. And then additionally, in the future, you should be able to use a custom allocator, which is sort of part of the extensibility of Unikraft, being able to have different memory allocators for different regions, having different schedulers for different regions, having different socket implementations for different purposes. So this is part of the goal. In the same way that we have Linux kernel modules, we register the interfaces with this glue. We just call a simple global function POSIX socket family register. But the key distinction that I'd like to point out is that now we can register something against a known AF number. So we have AF-INET here. Previously, I would have had to specify AF-Xen if I wanted to use the XenSocket implementation in the original XenSocket paper. They provided the Linux kernel modules. If they were not installed, this would fail entirely. For newer versions of Linux, the AF-VSock implementation would also not necessarily work. So here we can completely bypass the IPv4 and TCP stack by pushing our implementation through registering the library, which is done through a make menu config. So this is the primer for how it is accomplished within Unikraft. The application suite and use cases for it are quite general at this point, but I was hoping to open up the floor and discuss potential additional implementations that could be used, additional libraries that could be ported, and kind of discuss any limitations that you might see with this primer, or ways in which it can be improved, and indeed finding ways that it could be used. So with that, that's this short presentation over.